Hello, dear teachers, fellow students. Today I'm going to talk about trigonometry, give a brief info about coordinate, which is also known as Walder's algorithm. Uh, I'll also talk about Bhaskara's scene approximation formula and the equation for it, and why do we use that formula. So let's begin. Here, as you may see, it's a straight angle triangle with an omega angle. The side opposite to the 19 degrees is called hypotenuse. The side opposite to the omega angle is called opposite, and the last one is called adjacent side. Now, there are some of trigonometrical values that matter in a triangle. I'll talk about sinus, cosinus, tangent, cotangent. For finding, for example, sine omega, we need to divide opposite to the hypotenuse. For cosinus omega, we need to do adjacent over hypotenuse. For tangent, we need to divide opposite side to the adjacent side, and the cotangent, for cotangent omega, we need to divide adjacent side to the opposite side. As you may know, in tangent and cotangent case, a tangent omega or x should be equal to 1 over cotangent alpha or omega. For same goes for cotangent omega, whereas cotangent alpha should be equal to 1 over tangent alpha or omega. Sinus over cosinus omega should also give us a tangent omega, and cosinus over sin omega should give you a cotangent omega. Okay, now I want to talk about special trigonometric values in special straight angle triangles. The common side of these triangles are they both are based on their angles. So, for example, when we take a look at the 45, 45 and the 90 degree triangle, the sinus 45 should be equal to 1 root 2, and cosinus 45 should also be equal to 1 root 2. Cotangent 45, since their sides are equal, should be 1, and so will tangent 45. So we may understand that the sinus 45 and cosinus 45 are equal, while the cotangent 45 and tangent 45 are also equal to. Now we'll talk about 30, 60, 90 degree triangle. We'll both have a look at the trigonometric values of 30 and the trigonometric values of 60. So the sine 30 is equal to 1 over 2. Cosinus 30 should be equal to root 3 over 2. Tangent 30 is equal to 1 root 3, and cotangent 30 is root 3. When we look at the trigonometric values of 60, the sinus 60 is equal to root 3 over 2, cosinus 60 is equal to 1 over 2, tangent 60 is equal to root 3, cotangent 60 should be equal to 1 over root 3. So we see a pattern there that cotangent 60 is equal to the tangent 30, and cotangent 30 is actually equal to tangent 60, and this goes on for sinus and cosinus as well. Sinus 60 is equal to cosinus 30, so we may say that these two angles both complete each other, and they are equal to each other. So cosinus 30 should be equal to sine 60, as we may know already. back to the times when I was learning trigonometry at first, I was I was kinda found that easy because of the simple equations coming from the simple explanations of sine, cosine, tangent, and cotangent. But now that this year, when we learned about it more, I had a little bit confused. I had a question mark, and it was the question that burned me out. What happens if its sides are not given and also it's not a special triangle? So, for example, how will I find sin 20? Zordic is the abbreviation of Coordinate Rotation Digital Computer. It's a hardware efficient uh, method that uses rotations and circular vectors to calculate wide range of elementary functions. These functions are generally used in whenever there is not such a great thing as a hardware multiplier, like mini microcontrollers or FPGAs. And since because Sordic is easily able to get it through because it only requires an addition, subtraction, bit shift, and table lookup. These actions are required. Uh, Whenever the first time that Sordic was invented was 1956 by Jack E. Walder at the Aeroelectronics Department of Convair, whatever. The aim of the first Sordic was to replace an analog resolver in the B-58 bomber's navigation computer with a more accurate and performant real-time digital solutions. That's what the real purpose is said. When we look at the applications, it actually shines from there. Sordic can be used in many technological devices and also many places such as image processing, communication systems, robotics, 3D graphics, software and hardware creations, general scientific and technical computation is also one of those applications that Sordic fits in. And also during that, Sordic uses simple shifted operations for several tasks. These were before after the invention of softwares and computer stuff. But what were happening before the computers and software devices? There is a formula for that, which is an application of numerical analysis, which is an area of mathematics and computer science that creates, analyzes, and implements algorithms for obtaining numerical solutions. The formula is called Bashkara-Elsin approximation formula. It was discovered by Bashkara in 7th century. But it just hasn't got a certainty, unlike the Walder's algorithm. So we would not get a certain answer out of those degrees. So the equation given with sinets is actually for ready measured angles and for circular vectors. The cosinus y is actually the basic, one of the basic and easy formula for Bashkara-Elsin approximation. In order to fit in modern math, the real equation is right like that: 4x times 100 minus x over 40,500 minus x times 100 minus x. During this process, I learned numerical analysis, brief definition, and the applications of numeral analysis, Walder's algorithm, which is actually sorted, brief